Hey, Walter Sorrells back with more tips for the knife maker. Continuing on with our series about making wood turning tools, we're going to crank out yet one more tool. Let's show you what we got. Okay, today's project, a parting tool. A parting tool is used to cut slits down into spindles when you're working on a lathe. Now, the important thing about a parting tool is you don't want the tool to bind in the cut and smash the crap out of your hard work. So, one designed to minimize binding uses a sort of diamond-shaped profile for the tool, and that's what we're going to be doing today. I'll start with a piece of 1095 high carbon steel, just like we've used in other projects. This one's about 1/4 of an inch by 3/4 of an inch by about 8 inches long. I'll begin by using layout fluid to mark a center line on each side. I'll also use this little marking gizmo I made to run parallel lines down the sides. It's not important how far in they go. You could scribe them with a nail or anything. The point is, I just want them relatively symmetrical. They're just going to be used as a guide for our grinding later on. Alright, now I'll go to the flat plating on my grinder and I'll grind 2 bevels on each side using the lines that I scribed as guides. Of course, you can also do this on a bench grinder. These grinds actually take a fair amount of skill to make look perfect. The good news is that they actually don't need to be perfect. All they are is a slight relief to keep the tool from binding in the cut, as we talked about earlier. So, if they look like crap, the tool's still going to work fine. All you'll lose is your pride, and of course the flocks of women who are attracted to guys who really can grind straight bevels. Alright, so now I've ground these bevels in, 2 bevels on each side, 4 bevels total, leaving room for a tang of about 2 inches. I'll go ahead and grind that tang next. And then next, I'll shape the profile of the cutting edge. It'll run back at about 60 degrees on each side, connecting right smack on the grind lines, so that all the lines converge right at the point. So now we have a pointy little tool shaped sort of like a dagger. Now I'll heat treat it like the other 1095 tools I've used in this series. So I'll normalize it like I did our other 1095 tools 3 times at about 1600 degrees Fahrenheit. In this case, it's a very thin tool, so I'm just going to oil harden it. This lessens the stress on the blade caused by water quenching and makes it less likely to warp or crack. I agitate it vigorously in the warm peanut oil to make sure it cools as quickly as possible. As I mentioned in an earlier video, 1095 is sort of on the margin between oil hardening and water hardening steels, so if you go with oil, you want to cool it as quickly as possible. And agitation, that is kind of shaking it around in the oil, will help you accomplish that. Now that we're done, file test it, check. Clean up on the grinder. And voila, there's the tool. Okay, now some disclosure here. If I were doing this again, I wouldn't make the parting tool out of carbon steel. Check this out. If you run a parting tool at high speeds and just crank away at full blast, as I did here, you can generate so much heat that you actually ruin the temper of the steel. This little blue spot at the tip of the tool here indicates that it probably reached a temperature in excess of 600 degrees at the point. That will cause the steel to soften. So I actually had to grind this off, regrind the point, and after that, I always ran this tool at slower speeds. It's not a big deal, but it's something I have to be aware of moving forward. So, how to avoid this? As in our second project, you can use high-speed steel or even cobalt. Now, as we discussed in the 11/16 inch spindle gouge episode, you can buy M2 steel preheated. So as it happens, you can actually find both M2 high-speed steel and M35 cobalt, both of which maintain hardness even when heated to very high temperatures, in the form of machine lathe cutoff blade blanks. A cutoff blade is the metal lathe equivalent of a parting tool. So I've found both M2 and M35 blanks from MSC Industrial Supply, which sells online as MSC Direct, in various sizes, prices running from $10 to $50 depending on the size. They're already heat treated, so all you have to do is grind them and put a handle on them, and they'll be more temperature resilient than carbon steel. Speaking of handles, let's put one on this tool. Now this is a fairly small tool. The handle follows the same general approach as we've already showed, so I'm not going to show that much. If you want to see the whole process, check out my first video in this series. Now the handle on this particular tool is made from alder, a very boring soft wood that really isn't ideal for tool handles in the first place. So why did I use it? Well, I was fooling around, and next thing you know I had a handle, so I was like, well, why waste it? So it's finished with paste wax, nothing fancy done to it. If you're using a boring wood like this, you can always stain it or put poly on it or something like that, and it'll look a little more interesting. But at the end of the day, this kind of wood starts boring and ends boring. That's just the way it is. If you enjoyed this video, please subscribe to my channel and check out my website, waltersorrellsblades.com, where you can find more of my work. You'll also find plenty more videos there that you can't find on YouTube, with very, very detailed information about all aspects of Japanese blade making. Also, like me on Facebook at Walter Sorrells Blades.